Hello, everyone. Hypothesis testing examples part 2. So here's another problem. So let's work through this one. Number 2, suppose we want to show that only children have an average higher cholesterol level than the national average. It is known that the population mean cholesterol level for all children is mu equal to 190, with a population standard deviation of sigma equal to 15. We get a sample of n equal to 25 children and find that the sample mean is the m is equal to 198. Do we have evidence that only children have an average higher cholesterol level, there's the key there, than the national average? Conduct the appropriate hypothesis test using alpha equal to 0.01 and state your conclusion in terms of this problem. Make sure to use APA style conclusions. So step 1 is to state the hypotheses. So in symbols and in words. So H naught, right? The null hypothesis is stated as mu less than or equal to 190 mg by dl. The research or alternative hypothesis is stated as mu greater than 190 mg divided by dl. So the null hypothesis in words is only children do not have higher cholesterol levels on average than the general population of children. The research alternative hypothesis states only children have higher cholesterol levels on average than the general population of children. Step 2 is setting the criteria, which is alpha is equal to 0.01. That's given, so you don't have to worry about it, right? So let's go ahead and move on to step 3, which is to calculate the test statistic, which is a z-test, right? We're going to conduct a z-test. How do we know it's a z-test? Because population standard deviation, sigma, is known and given in the problem, right? So again, I pull out the numbers that we're going to need in order to do our z-test. So mu is equal to 190, sigma is equal to 15, n is equal to 25, sample mean is equal to 198, and alpha is equal to 0.01. So let's go ahead and scroll on up. And here we go. Here is step 3. So remember in the previous video, I said always do your standard error first, what's in the denominator, so that you don't have a fraction in the denominator, right? So our first step is to figure out standard error, right? So here's standard error. Right? Sigma m is equal to population standard deviation divided by the square root of n. So 15 divided by the square root of 25 gives us 15 divided by 5, which is equal to 3, right? So our standard error is equal to 3. So our z-test, now what we need to do is plug in our numbers, right? Our sample mean minus mu divided by standard error. So 198 minus 190 divided by 3 gives us 8 divided by 3, which is equal to 2.667, which gets rounded up to 2.67 again, so that we can make sure that we look up the z critical value. Oh, and I forgot, once again, what are we looking for? So let's go ahead and draw this out. So here is mu, which is 190. Here is 198. And we're looking for, right, for scores higher, right? What's the probability that an only child would score more than 198, right? Or would have a cholesterol level that's higher than 198. All right, so now that we know we're in the tail, right, we can pop over to our z-table and look up 2.67 to see what the probability or what the area is. What's that area in the tail? So remember our z-table. So let's go ahead and go to 2.67. Scroll down, scroll down, scroll down. Keep going. 2.67 is right here. So 2.67 in the tail. The area is 0.0038. So our probability, or the probability that an only child would have higher cholesterol levels than 198, is a probability of 0.0038. So that's pretty low. That's actually super low. All right, so let's go ahead and come back to our problem. So 0.0038. This probability is lower than alpha 0.01. So our decision, here's our decision, step 4, right? We make the decision, we reject the null. And now we have to, remember, we must calculate the effect size because there is an effect, there is a difference here. So we're going to do Cohen's d. And if you remember Cohen's d, d is equal to m minus mu divided by sigma, right? So it's 198 minus 190 divided by 15. So 8 divided by 15, which gives us a d equal to 0.5333. Right? And next is to write this out. That's the last part of the problem, is to write a APA style conclusion. So here it is. Reject the null. There is sufficient evidence to conclude that only children have significantly higher cholesterol levels. Remember, it's comma, and now we have to provide the statistical evidence, right? Back it up. So Z n equal to 25 is equal to 2.67, comma, p is equal to 0.0038, comma, d is equal to 0.53, comma, medium effect. If you remember from the table in chapter 8, a d of 0.5 is a medium effect, right? And now the last sentence is just to say this in English. What does this all mean? Only children have significantly higher cholesterol levels on average than the general population of children. And there we go. We've done our second problem.